Hello and a very warm welcome. Myself, Martin Scheurer, and my colleague Shantanu Bhatt will present to you textile reinforced precast technologies, an Indo-German collaboration for reviving the construction industry. Today's presentation is separated into 4 parts. First, I will introduce the Institute für Textiltechnik of RWTH Aachen University and the Department of Construction Composites at ITA. Afterwards, my colleague Shantanu Bhatt will showcase ITA's collaborative activities with India and how to revive the construction industry using textile reinforced precast technologies. The Institute für Textiltechnik Aachen has a staff of about 100 scientists working in all areas of textile development, textile production, and textile application. In addition, we boast about 60 technical and service staff, 190 undergraduate research assistants, and about 50 students who major in textile engineering every year. The expertise of the ITA reaches across the whole textile production chain, starting with fiber production, continuing with yarn and fabric production, and reaching into composite and semi-finished part production. This large area of expertise allows for a multi-scale formability across all process stages, where the needs of the semi-finished parts can be incorporated even into the fiber production, and products and developments can be tailor-made for each and every application. The ITA focuses on 8 research domains as shown on this slide. These are building and living. Part of this research domain is, of course, the Department of Construction Composites, as well as the research domains of energy and environment, mobility, production, information and communication, health, materials development, and qualifications. The Department of Construction Composites at ITA focuses mainly on the area of building and living. The department consists of 5 researchers, as shown in this picture. One of the main topics of the Department of Construction Composites is TRC, or Textile Reinforced Concrete. The basics of this new material are showcased in this slide. Textile Reinforced Concrete is a composite material consisting of 2 parts. The first part is the fine concrete, which is with a fine concrete matrix of aggregate sizes of up to 5 mm with adjusted flow properties offering a very high surface quality. This concrete is then reinforced using a textile reinforcement, which replaces the traditional steel reinforcement. The textile reinforcements are made of carbon or alkaline-resistant glass rovings with teters up to 3,600 tecs. These textiles are usually fashioned into a biaxial warp-knitted fabric or a 3D warp-knitted fabric, and both parts of the composite are placed together, resulting in TRC. TRC composites are corrosion-free, since the reinforcement does not corrode, dissimilar to traditional steel reinforcement. In addition, TRC composites are structurally strong because especially carbon fibers, offer very high strength. They offer a high design freedom and a negligible concrete cover. So textile reinforced concrete offers many advantages over traditional steel reinforced concrete. The reinforcing materials are usually carbon and alkaline resistant glass, as mentioned before, but in addition basalt fibers and polymer fibers, for example aramide, PVA or PP fibers, can be used. Here, the reinforcing materials can be tailored to each application. For example, if very high strength is needed, carbon is the material of choice. But of course, carbon fibers are quite expensive. So if less strength is suitable, it's better to use alkaline-resistant glass or basalt fibers. Why should you use textile reinforced concrete? In steel reinforced concrete, the concrete bears compressive forces and the steel bears tensile forces. This combination of material properties has led to the high success of steel reinforced concrete, making it the most important building material globally. However, the reinforcement is corrosion prone and requires a thick concrete cover, leading to high weight of the materials. Of course, steel reinforced concrete also offers a wealth of experience with more than 100 years of the material being in use and many general building approvals being available. However, the transition to textile reinforced concretes offers resource savings of up to 80%, leading to reduced CO2 emissions of up to 80%. Thicknesses can be reduced, depending of course on loads, by up to 70%, and the weight of building materials or precast elements can be reduced by up to 50%. In textile reinforced concrete, the principle remains the same. The concrete bears compressive forces and textile bear tensile forces. However, the reinforcement is not corrosion prone, leading to thin concrete covers, less weight. Still, the material is relatively new, with first experiences being made about 20 years ago and no general building approvals being available yet. Here at ITA, we do not only focus on TRC, but also on other composite materials. Especially, of course, as a textile institute, we focus on the textiles for reinforcing, for example, the TRC. These are biaxial warp knitted fabrics, which we can produce here at our institutes. In addition, we focus on intelligent textiles and product by functional integration, by means of using technical textiles. And these technical textiles can offer a wealth of additional functions, for example, surface heating, sun protection, heat protection, etc. In addition, we also study 4D textiles, which are facade textiles that can adapt to environmental influences over time by textile integrated mechanisms. For example, closing a sunshade if the sun is high in the sky. In addition, we've researched shaped fibers for acoustic insulation, for example, used in office spaces or in event locations. Another focus of our institute is sustainability. Here we develop new sustainable resource-efficient materials, such as TRC. One very important topic for TRC is the design for recycling of textile reinforced concrete, where we already plan now for reuse of buildings built with TRC after their lifespan of up to 80 years is exceeded. In addition, we research the application of recycled short carbon fibers in concrete and mortars, and we do efficiency analysis of composite production processes to decrease material and cut-off waste. Another area of research is in geotextiles, where we do machinery development for production of linowoven fabrics with high grid sizes as suited for geotextile applications, and we work on integration of warning systems in building and dikes to prevent natural disasters by using smart textiles and integration of sensors. By integration of sensor fibers, for example polymer optical fibers, carbon fibers, or other sensor fibers during the textile production, so that the sensor is integrated directly into the geotextile, and the geotextile can be used for reinforcement and sensing simultaneously. All these developments we do at our institutes are not only theoretical in nature, but we have also produced a lot of demonstrators over the years. For example, in 2009, while just building our new machinery hall, we built halls with the first TRC sandwich facade worldwide, and the facade still looks as good today as it looked the day it was built. In addition, we developed light transmitting concrete facades in cooperation with the industry, functionally integrated TRC roofs, which integrate either photovoltaics or thermics into the roof elements, and we developed curved concrete elements, as showcased in the pictures on the right, which show that textile reinforced concrete offers highly adaptable thin structures with thin-walled elements for architectural purposes and to reduce weight and improve resource efficiency. We offer here at ITA a cooperation along the entire value chain, starting with the textile development and with 2D and 3D warp knitted reinforcement textiles, as well as lino weaved textiles. Continuing with textile finishing, where we do coating of textiles on lab and pilot scale, and the sensor fiber integration if necessary. We also allow for prototyping in our concrete lab, where we manufacture prototypes as well as standard testing specimens, and we also have a polymer infusion labs analyzing polymer coating materials. And we have an acclimatized testing facilities where we can do fiber, textile, and composite testing, as well as optical and electron microscope tests, as well as an X-ray CT.
Thank you very much, Martin. Hello everyone, I'm Shantanu Bhatt from Construction Composites Department at ETA. Over the next couple of slides, I would like to share with you ETA's collaborative activities with India over the past couple of years, and also how we can together revive the construction industry using textile reinforced precast technologies. Our institute has been working in close collaboration with different universities and industry partners in India. In 2019, the Indo-German Science and Technology Center governing board meeting was held here in Aachen, Germany. The main purpose of the meeting was project initiation of two Indo-German projects granted to ETA and IIT Madras along with their industry partners from Germany and India. Delegates and technical experts from IIT Madras and IGSTC visited ETA to discuss and devise a plan for the execution of the two projects, Clean Water and NearNet MAC, which will run until 2022. The meeting was also attended by Consul General Ms. Pratibha Parker of the Indian Embassy in Frankfurt and Professor Thomas Gries, Director of ITA from the RWTH. In the impressions on the slide, we can see my colleague from ITA showing the board members and the delegates the facilities at ETA for the development of textile-based solutions. Moving ahead, at the third Indo-German Symposium, topics and opportunities for innovation and entrepreneurship in Germany and India were discussed. The focus was on startups and cross-border opportunities to channelize the developments made in the textile field at ETA into the Indian market through campaigns like Make in India and other government initiatives. Now I would like to throw some light on one of the two projects which were initiated at the IGSTC board meeting which I have mentioned before. The project name is Clean Water and the goal is development of modular lightweight wastewater treatment units made with TRC for rural and peri-urban dwellings. The project was initiated to tackle problems of untreated wastewater which is being discharged into the environment. Many regions have no access to wastewater treatment plants and also the high energy and space requirements which the current systems need. Hence, the aim was to develop, manufacture, and implement a modular, low maintenance, energy saving, textile reinforced concrete wastewater treatment plant. Using textile reinforced concrete, the sewage plants can be made modular and of low maintenance. And the approach adopted for this project was to first of all develop a design for TRC wastewater treatment plant. Secondly, to verify the load bearing capacity and suitability for use of the sewage plant at the respective site. And at last, to develop a transport system so that this wastewater treatment plant could be set up even in the most secluded villages in India. We at the Construction Composites Department at ETA are glad to have carried out projects with countries like Canada from America, Korea, Japan, and India from Asia, amongst others. And this has helped us develop a widespread international network which keeps us up to date regarding the recent advancements in the field of textile reinforced concrete. For some of our target countries, we also have dedicated country representatives which cater for the hassle-free coordination of the project activities. Now I would like to come to the last part of our presentation and share with you the views of our department and how we think we can revive the construction industry using textile reinforced precast technologies and be prepared in future for unprecedented calamities or more specifically pandemics like COVID-19. Now I would like to put forward two research topics which we think will be beneficial for the revival of the construction industry. Firstly, textile reinforced 3D concrete printing. 3D printing has already found its way into the construction industry. There are already houses being 3D printed, but the deficit at the moment is that the 3D printed concrete doesn't have any reinforcement, and hence the absorption of the tensile forces is only possible via the matrix, which in most cases is not that strong enough to sustain the forces which act upon the building. And thus, the aim is the realization of endless fiber reinforced 3D concrete printing process. The approach which can be adapted for 3D printing of endless fiber concrete is with the help of robots and textiles, and hence we aim at development of a process for the production of 3D textile reinforced structures. Another way in which we can revive the construction industry is by using the adaptive molding technology for the manufacturing of doubly curved textile reinforced facade elements. Often is the case that when we go for freeform architectural buildings with complex shapes, as the one shown in the top right corner of the slide, the mold costs for such a building are 35 to 60% of the total production costs, as for each element of the facade a different mold needs to be fabricated, which makes the whole molding process very cost intensive. And also, if we don't use textile reinforced concrete, then the facades also become very thick, which then limits the freedom of design of these facades. Hence, the aim here is the realization of non-repetitive, doubly curved, thin-walled TRC facade elements with the same adaptive mold. Here with the adaptive molding technology, a set of pins take different shapes when they move vertically with the same mold, and hence it is possible to fabricate both repetitive as well as non-repetitive facade elements with the same mold. And the approach which is to be adopted here is first of all to develop a drapable textile reinforcement for thin complex shaped facades. Here a multi-axial textile grid structure which is drapable will be developed, and then this developed textile will be used with the adaptive mold for manufacturing of thin walled facades. Apart from that, a suitable concreting process for fabricating TRC facades over the adaptive molds also needs to be developed. Now I would like to go through the ways in which we can work together on the topics which we find interesting, and also of course on the topics which you think could be of interest for both of us. We can work together via public projects which are financially supported by the respective governments and the funding instruments through student and scientist exchange programs and trainings. Also, uh, we can work together with the sister concern of our institute, the ITA GmbH, in form of R&D projects which cater to the industry company industry and company specific needs framework contracts such as MOUs between universities, innovation workshops, literature and patent research, student theses, training courses. These are exclusive to the needs of our partners, and there is also arrangement of confidentiality so that whatever is being developed is not publicly available. Now I would like to summarize our today's presentation in a nutshell. ITA is leading textile research institutes in Europe with more than 20 years of experience in textile reinforced concrete. The first tests on textile reinforced concrete were done at our institute back in 1998. TRC offers multiple advantages over steel reinforced concrete like higher strength, less weight, eco-friendly, and resource efficiency, which makes TRC suitable for precast elements. And thus, TRC enables a sustainable revitalization of the construction industry as due to the lightweight, transport costs are being saved due to the material efficiency, less cement is being used. We are constantly looking for research partners with whom we can collaborate and further develop the textile reinforced concrete technology.